In this video, I want as we understand the completing the square method as a way of solving quadratic equations. Before we learn how to use it, it is important that we learn what it is and how it works. It is frequently useful to rewrite quadratic expressions by completing the square. And every time you have x squared plus bx, when you use completing the square, we always talk about x plus b over 2 squared minus b over 2 squared. But let us see where this one is coming from. How is this side equals to the right hand side? So you can have a rectangle of this dimension. I just want to illustrate how this one is possible. If you have a rectangle that is having dimension x, and this is x plus b, and having said this is x plus b, I want to divide it into two so that we can have this part from here to here equals to x, and from here to here this is b. The area of that rectangle, is x times x plus b, and this is what is giving us x squared plus bx. If we may want to rearrange this rectangle, we may wish to do something here. Let's see what happens here. We may wish to have it as a square, and at that particular point this is x. If we say this side is x, from the original rectangle we may be interested to divide this particular portion by 2, and then we pick this portion whose width is b over 2, because from here to here we have b. The width of this part, as we can see, is b divided by 2, and the length is x. If we pick this portion which is now shaded, if you pick the shaded portion and bring it here, it will exactly fit along the length of x, because this is x, and its length was also x. So you will find this particular portion b over 2, and this is x. Having picked this rectangle from here, you left this unshaded rectangle, of course, here with its width b over 2, and the x was not interfered with. So you can see our rectangle, which was there originally, has changed into a figure that looks like this. Of course, we have a square which is measuring x by x. Beyond that, the height, we have a rectangle whose length is x and height is x over b over 2, and on the other side we have a rectangle whose width is again b over 2, and the length is x. So you can see we have a rectangle which has been rearranged into this particular figure. But what I want you to look at is that this square is not complete because it is lacking that portion. it is lacking that portion. So the area of the whole of the original figure is equals to the area of this figure minus that portion. But what is, or what are the dimensions of that portion? You can see that portion is b over 2, that length is b over 2, and according to the rule of the law of the rectangle, that side is also equals to, this side is also equals to b over 2. So it is a square that is lacking here. So we can say the original rectangle whose area was x, x squared plus bx is equals to, because we have changed nothing, x squared plus bx is exactly equals to the length of this one times the width, having considered the whole of the square, of course, minus the portion that is lacking. And what we have there, x plus b over 2 squared, because this is the same length, which is also reflected here, minus the portion b over 2 times b over 2, which is b over 2 squared. So because the areas of the original figure should be equal to the area of the new figure, then it is mathematically believed that this is quite convincing and correct. So basically, this is the whole idea of completing the square. And we're going to see why do we need to complete the square? How do we use completing the square method in solving quadratic equation? But this is quite important. It is important to understand the moment you hear completing the square, where does it come from? And is it mathematically correct? Yes, it is, as it has been explained in this video. All right?